A very good morning to the Vice Principal Sir, Coordinator, Co-Coordinator, to our resource person, participants. A very good morning to one and all, and a warm welcome to our FDP sponsored by AICT Atal on recent developments in high performance semiconductor devices and their applications. Day 3, Session 5. Today our resource person is Dr. M. Asharani Ma'am, Senior Professor from JNTU, Hyderabad. Ma'am has submitted her PhD thesis on design of built-in self-test and repair scheme for static ramps and published 6 technical papers in national and international conferences. She is a coordinator for one TAP TEC project of Rs 6.5 lakhs and in establishing VLSI lab and one R&D project of Rs 9 lakhs in designing an ASIP for image processing application sponsored by AICT Delhi. Coordinator for Spooty 2004 a student symposium, coordinator for freshers courses conducted by ACAD Staff College, JNU Hyderabad. She has attended about 10 workshops on VLSI EDA tools designed for testability, national instruments, virtual instruments, LabVIEW, etc. Ma'am is also a supervisor and co-supervisor for many PhD scholars as well PG scholars also. She held responsibilities as HOD, JHUB Director, EDC Chairman, as Chairman and of various committees in JNTU Hyderabad, and many more to her credits. Ma'am is also a Board of Studies member in various engineering colleges in and around Hyderabad. She is a senior member in professional societies of IEEE, ISTE, also a reviewer for national and international journals. She delivered many lectures as a guest and expert speaker as well as keynote speaker in conferences. Ma'am has organized many seminars, workshops, conferences as coordinator as well as convener. Her areas of interest are digital system design, design of fault-tolerant systems, microprocessors and microcontrollers, VLSI design and embedded systems. With this brief note, I would like to welcome today's resource person, Dr. M. Asharani Madam from JNTU, Hyderabad. I request our Vice Principal Sir to present the bouquet to Ma'am.
కొంచెం ముందుకు రా, లైట్ పడుతుంది, లైట్ కొంచెం
EC departments, AV and IAT. I would like to convey from my bottom of the heart my sincere thanks to today eminent academicians, the senior most professors from JNTU H, Dr. M. Asharani. So I hope everybody knows that the madam busy schedule. So in spite of that, madam accepted our request and madam came today and enlightening our program and also enlightening the faculty and the student knowledge. So because of once again EC department, AV and IAT, I would like to convey my sincere thanks, madam, for accepting our invitations and may your presence today. Really, we all are blessed and lucky.
Academic achievements what I have, of course, we teachers will be concentrating on publications. It's not limited to 5 or 10 or few numbers. With the help of my scholars as well as my own contribution, I could go up to 72 publications till now. And one interesting feature is, apart from R&D projects, what I have done with the sponsorship, one more very big achievement with the help of MSME funding and all. I have gone for fund from DST and the release scheme. Now I am granted with 7 by name JNTU Innovation Foundation, a technology business incubator in our campus. Within 2 years, after COVID, within 2 years we could generate or rather see to that 26 startups are there in the campus working. And out of those 26, 3 of them already graduated this year. And very successfully the ecosystem is working with us. Thank you for inviting me for the presentation on this FDP program. But I was hesitant in the beginning, even now, after listening to the resource persons who were present last couple of days. I'm not a semiconductor engineer. I'm not a pure VLSI engineer. I feel, and my abstract level of designing is up to RTL only up to FPGA designing. However, the concept what I have picked up for this presentation, it is a bird's eye view on system on chip. What exactly is the definition of a system on chip? Maybe you know it, but you should be felt how complex it is. What is the advantage? What are the disadvantages or the limitations in designing a system on chip? What challenges as a design engineer tomorrow you have to face, and what is going to be the next step for us to take future. So I came to know that already in tools, VDA tools or the layout tools, you have to break your head while trying. After the layout is done, all of you try to do some sort of analysis, maybe static timing analysis or the power analysis or some sort of analysis will be done by you. And once you are not satisfied with the outcome what you have analyzed, again you go back to the initial stage or to some stage in your layout, you try to do some modifications or you try to adjust the design layout in such a manner it is going to meet the specified requirements. But the question here is, again and again you are starting from the beginning. Why don't we use some tools, again using either machine learning or deep learning, to do the layout such that with the earlier knowledge or earlier existing layout information which your network has been designed with the help of deep learning, with the help of machine learning. This is what we are trying to do here. But my subject today is not to look at a chip or one single chip solution for you, but it is going to be a system on chip, or in short we call it as SOC. So that's what actually I wanted to put SOC design, but some of the basic things, though you know, I have to start from this question now. I should start from one statement. How do we define that? What do you mean by system on chip? As all of you see that from the very definition, the entire system, flexibility is provided, so they become soft. Soft means flexibility is achieved. Hard means no flexibility. ARM processors are there. Application specific processors like DSPs are there, or assets are there, who are going to carry out for us element 1, processing element 2, processing element 3. All three of them are using the same memory. Unfortunately, there is one application simultaneously running on these two processing elements. One of them is accessing an address X of the memory. This is also accessing X of the same memory. This fellow is reading, the other fellow is trying to write simultaneously. Of course, nothing is simultaneous. There is some scheduling algorithms running in the system program on your schedulers, which will be scheduling to use this common resource. I think you all know about the shared resources in the embedded system environment. So what happens? How does it work? Some semaphore will be there, or some inter-task communication mechanism will be there in the kernel of operating system. So that will know that the scheduler or that synchronization software will be taking care. You do first, you do second. Unfortunately, I wanted to read from X the value called Y. This fellow wants to read the value from an X location having Y. Before I read, that fellow has given chance first to that PE. This PE has already overwritten his data, made it Z. What is that I receive at the end? Because it's sequence. I will be getting Z, but what is expected by me? I should get Z. Why? So, a care has to be taken in shared bus mechanism, shared resource mechanism. So, a proper software has to be developed by us to handle such collisions or handle such synchronization issues. So, the other alternative what we have for message passing is network on chip. This is much used in SOCs where it is possible for you to scale it up, and you can also transfer your required data without much overhead. how the shade bus NOC looks like. Network launching, every component on it is placed in such a manner they are communicating with one another. Whereas on the left hand side, you see multiple buses are being used to interconnect different blocks on your system. Okay? So, up to this point.
First of all, I feel honored to convey thanks to our resource person. Firstly, I convey my sincere thanks, sorry madam, because we are actually not updated with your profile. So very sorry for it. And I convey my deep gratitude to you.
I should must update in my website.
Even we have to get updated. So I really feel honored to convey thanks to you, madam. First of all, for accepting the invitation and coming to our campus. Next, you have shared your experiences and you have enlightened our knowledge on SOC design. We have known to some extent, but with this lecture, we have understood what actually is SOC. And thank you for sharing all this knowledge to us. And we are very much honored to listen your lecture actually today. We have just heard about you, but we have never seen you because in this participants, 2 students are there who are actually your PG students. So we have been hearing about you, but today we have witnessed your lecture. So thank you very much, madam. And I really thank the coordinators for calling madam to our campus for this lecture on SOC design. So thank you everyone. Now I request our coordinator and co-coordinator to felicitate resource person.
See, I have a responsibility here with this department, being a board of governors, so board of study member. I wanted to visit this campus long back. I thought I got an opportunity to visit, so that's why I'm here. Otherwise, if proper time has been given to me, I would have chosen design for testability as one of my topics. No, I don't know. When it was told semiconductors, I was stuck at some topic. Anyway, sometime later we will see.
Thank you, ma'am. Thanks a lot. Even we forgot our break also in between. It flow. It went on with a very nice. Even we also learned many things from SOC, what is going on right now in real-time applications. So thanks a lot, ma'am, for accepting and made your presence and given a wonderful lecture to our participants. Thank you a lot.
I could have organized it with better design flow for one of the examples. Sorry, I'm very sorry for that. I should have come prepared with some more design done in front of you with some
Definitely, ma'am. If time permits, definitely we will invite next
you can visit us. And one more request is being faculty, please do visit once of the TPI just to know what is happening there. Maybe somewhere you fit into become a mentor to someone, or maybe a co-founder later on at some point of time, or some research project can be carried out. Skill development programs can be conducted along with you in the campus. Maybe you become a resource person. Please visit. I know it is a bit far away from this place to come every time, but you can make it.
Definitely we will visit, ma'am. Even starting itself, we shared some idea for TVA. Definitely we will do, madam. Definitely we will make association with
Our Vice Chancellor sir is so particular. Whenever I meet him to explain the progress, he keeps asking how many of our students, our college or affiliated college students are getting benefited. You tell me when. Unfortunately, student community after passing out, now that 2010 batch, now they are in the campus all the way from Visakhapatnam for 2 days park program. They have come. 18-week program. Demo day was for 2 days. All the way from Visakhapatnam they have come to grace and encourage the students. So they are now finding it very useful to become an entrepreneur. So you can motivate your students and you yourself can become a student. Need not be like you register, sit there, have a company. No. You can have one intellectual property of your own, sell it, do your work, again you start a new IP. You can do that.
Yes,
People are there to purchase.
definitely we will approach JHub also. We will put our request with permits. JNTH. We will ready to organize the JHub hackathon in our campus if we are permitted. So when I was in Spooty College, that time we organized JHub hackathon in Spooty campus. That's it.
Actually, JHub is a place for students for pre-incubation. Means motivating them towards entrepreneurship, a year-long program for pre-incubating. After pre-incubation, when their ideas get converted into a product, they are given a startup status in our PBI. So that is the flow. JHub is different, PBI is different. But we are also doing pre-incubation programs on our own, hackathons also on our own. We have a very beautiful drone labs are there, AR/VR is there. Excellent. They are really working with defense projects are there for them to work. We are having excellent IoT interspace facilities are there, IoT are there. PLCs are there. You can come and
I understood you really missing opportunities at whatever providing by the university. Still we are searching the industry outside for industrial research and that, but we are not thinking to visit our own industry.
no, you can come and talk to them. Some people are using GPUs. I was really thrilled to see the way they are performing. Two companies are working for army, one company, another one is for defense labs. Both of them in collaboration are working again for defense labs. So the ecosystem has evolved. Now. 7 crores. Then I can anytime. Just give a call. Our program manager, CEO, and others will be there. They will help you, they will teach you, convert your ideas into which, and then funding will be arranged. Minimum of 25 lakhs to 1 crore is what we are doing.
Thank you, madam. Thanks a lot. Please accept small police stations. It's a formal only in the city program. Participants also please join us.
Bro,
Participants please come back.
done.